Right, today we're going to talk about the free radical substitution of alkane to form haloalkane. So we're going to have one example, which is I'm going to write the overall equation. Overall equation, I'm going to use methane as an example, plus chlorine with UV radiation. You end up with HCl plus CH3Cl, which is chloromethane. So that's your overall reaction for this free radical substitution reaction. So the mechanism is called free radical substitution reaction, and is the main reaction of alkanes that you have to remember. So we start with initiation step. There's 3 steps to this reaction. Initiation. Okay, so initiation is when the chlorine is broken down to form 2 free radicals by UV radiation. So those free radicals are now present. They will attack your methane molecule, which is your alkane. So you got the propagation step next. There's 2 steps in propagation steps. You have your methane reacts with your free radical. So the free radical is very reactive, and he wants to steal one of hydrogens from this methane molecule. So he steals one, so he forms HCl, so he's happy now, and then leaves the CH3 free radical now. Very reactive there. So the CH3 free radical now is desperate to get something attached to it. So he's going to react with the Cl2 molecule. So he's going to take away one of the chlorines in here, and he's going to form the CH3Cl, which is chloromethane, plus you have the free radical still come back again. On the 3rd step, which is called the termination steps, there's 3 termination steps. So you can take all the free radicals that is formed, and they will bump it together and they form a bond. So if I have 2 chlorines free radicals, if they hit each other, they will form a bond and chlorine molecule is formed. Second one, you can have the CH3 free radicals together. They react together and they form a bond, which is CH3, which is ethane is being formed. And on the 3rd step, you can have one of these, which is a CH3 free radical plus the Cl free radical, gives you the CH3Cl formed in the last step. So this is the same, the haloalkane that is formed in the propagation step. That's the intention to form this reaction, the intention to form in this reaction. Now, the limitation of these reactions are, they are further substitution occurring in this reaction. So the further substitution is every hydrogen here are going to be replaced, every hydrogen in CH4 will be replaced by a chlorine. So the first product is CH3Cl. You can have the second product, you can have CH2Cl2, which is this next hydrogen is gone, it's been replaced by chlorine. Then you can have CHCl3, another one is being replaced by chlorine, and then you have CCl4, which is all the hydrogens being replaced by chlorine. So that is the limit. There are the limitations of these reactions. Okay, so that is your free radical substitution mechanism for you to remember. Thank you.